Nothing in fisheries changes fast. Perceptions are built up over time, and you don't change those perceptions overnight.
Forage fish are a very sensitive and controversial issue because they're so economically important, they're socially important, and of course they're really important to predators in the ecosystem as well. This new paper does significantly advance our understanding. It provides a different perspective.
Our research speaks to a debate in fisheries science and marine conservation about how to manage forage fish, whether there are benefits to taking an extra precautionary approach.
Are the predators really gaining very much? And this study would say, in most of the instances we've looked at, we don't have evidence to say that's the case. Now, I'll caveat that by saying that isn't true for every case. As always in fisheries, one must be very careful with drawing conclusions that are too general.
It's saying that some of the big studies, such as the Lenfest Forage Fish Task Force study, which I was involved in, as well as the Smith et al. Study on forage fish, those suggested we need very precautionary targets for fishing forage fish so that we protect the dependent predator species. This study suggests that those are too conservative, that in fact you can fish heavier and you're not going to detect a signal on the predators. I don't see it replacing any of the previous work, but complementing it. I stand by the need for being quite precautionary. Unless you have information to show, you don't need to be so precautionary.
Nobody has seriously argued that overfishing of forage fish is a good idea. That is, fishing them at a rate that would exceed the maximum sustainable yield. That would be bad economic policy as well as a conservation risk. We tried to go as empirically as possible.
We assembled a database of forage fish abundance that goes back until the 1950s, 1960s for many populations around the world. And we also assembled a database of predator population size over those same time periods. And we were able to link up those two data sets to ask the question, how has prey abundance influenced the population growth rate of these predators from all around the world?
And ask whether the ups and downs in the forage fish populations correspond well to the ups and downs in their predators.
We looked at 45 predators from 5 different regions around the world, and our predator populations included fish, they included seabirds, they included marine mammals, and we looked to see how many of those have been positively influenced by increasing forage fish abundance over the last 60 years. And we found that only 6 predator populations of those 45, 13%, have actually been positively influenced by increasing abundance of their prey. And our work suggests that the sustainable limits that we already employ are sufficient for maintaining forage fish abundance above the thresholds that are necessary for their predators.
It is saying that predators also are perhaps more resilient than we've given them credit for.
Predators are highly mobile, they have high diet flexibility, and they can go and look for forage fish in places where they're doing well, switch species for species that are doing well, and have often evolved to breed in places where there is high and stable forage fish abundance.
Where are you fishing? If you're fishing right by the breeding colony and you're impacting the local abundance to the extent that those predators have to travel much further or work much harder to find their prey, then you start getting an impact. So I think it is very case specific.
So what we've done here that's different from previous analyses is try to control for some of the other factors that influence predator and prey population dynamics. In this case, we included in the models a covariate representing ocean temperature.
They show that temperature can actually be more important even than changes in the abundance of your forage fish. And I think that's critical finding.
Our approach really allowed the data to speak for itself. So we had a model for how we expect predator populations to grow, and we allowed the abundance of their prey to influence the magnitude of their growth rates.
What it's broadly suggesting is that the level of forage fish abundance at which predators start to feel the pinch, if I can put it that way, is perhaps lower than we've been assuming in our conventional models. But that isn't going to hold in every case. And at the end of the day, if you're going to talk about managing a particular circumstance, you have to look at the circumstances of that scenario as well.
You can argue with more precaution, right? But in this case, what that means is not fishing the forage fish populations as much as we could sustainably. They obviously provide economic benefits to the fishery, but eating fish at lower trophic levels, that is lower on the food chain, it is generally more sustainable than eating the top predators of the ocean.
Your paper did focus on more well-managed fisheries, and I think that's possibly why you don't pick up a strong fingerprint of fishing. I think you pick up those signals at the lower levels. I think you can manage the risk if you have good data and good information. Where fisheries don't have good data or good information, I think you do have to be quite conservative.
In places of the world where we already have really strong, very effective fisheries management, additional limitations on forage fish catch are not likely to benefit their predators.
Management of forage fish populations should be based on data that are specific to that forage fish and to their predators. Second, when there aren't sufficient data to conduct a population-specific analysis, it's reasonable to manage forage fish populations for maximum sustainable yield, as we would other fish populations under the Magnuson-Stevens Act.
To my mind, the next step, I guess, would be to really show that you're not increasing the risk of dropping to those lower levels if you drop that target down. Fisheries are the easy scapegoat. People will say immediately blame the fisheries, it's because there's too much fishing. And I think this study supports previous work and other work as well that shows that sometimes actually the environment is the biggest driver of those changes. And we need good rigorous science like this in order to separate the effects of fishing and the effects of climate. Because if we don't understand which of those two is driving declines or changes, we're not going to target our management correctly.